In this video, we are going to go over section 4.5, absolute maxima and minima. The goal of this section is to find those 2 points, absolute maxima or minimum, on an open or closed interval. What is absolute maximum and absolute minimum? Well, absolute maximum is the highest point of our function value in any domain of x, versus absolute minimum is the lowest, smallest point of our function value in all of the domain of x. Now recall back in 4.1, we talked about relative maximum versus relative minimum, and don't get confused with between the two. If you look at the definition of local minimum, local maximum is at certain range of a value. So we looked at it for negative and positive, and then positive to negative. Now in our section 4.5, this has to do with for all x value in the domain. Okay, so for example, let's say you have a curve something like this. Okay, relative minimum is the smallest point. So let's say you have a function that looks kind of like this. Okay, then relative minimum in a closed interval or open and closed interval, that's the smallest point. So that means I'm going to find the smallest point, so that's at negative infinity. Maximum is keep going. I can keep finding the bigger value, so at positive infinity. Let's say the graph kind of ends in a closed interval, something here, not arrow sign. That means this is the absolute max. That means that's the highest point on our given domain. So just remember that absolute means the highest maximum point, and then lowest minimum point. So we have a couple theorem to help us to find the absolute extrema. Let's take a look at the 3 theorem. Number 1, a function f is continuous on a closed interval a comma b has both absolute max and absolute mean on that interval. So any continuous function in a closed interval, so we are talking about that has an ending point, has a both absolute max, absolute mean. Absolute extrema, if it exists, must always occur at the critical or end point. So in the past, we didn't care about the end point. Now we have to consider that the critical value can occur in any interval or at the end point. Because we saw example that absolute maximum can occur at the end point. So it's very important that you include end point. Second derivative test is useful in determine the absolute minimum or maximum. So let's take a look at second derivative test. Let f be the continuous on an open interval with only one critical value. Then that critical value is absolute minimum if you plug it into the first derivative function and equals 0. And the second derivative value is positive. Vice versa. The critical value is absolute minimum if the first derivative at that c point is a 0, and then second derivative at that point is a negative value. So these are the 5 steps that we are going to go through to find the absolute value. We are going to start with f being continuous function, because we need to have a continuous function to find out absolute max and mean. Find the critical point. And then recall earlier in chapter 4, we found the critical point by setting the first derivative equal to 0. Evaluate f at the end points. Here, we are adding one more step of checking the end point because it can occur at the end point. And then number 4, absolute maximum is the largest value found in step 3. Absolute minimum is the smallest value found in 3. Okay, so let's go ahead and look at our first example. Number 1, find the absolute maximum and minimum. So we need to find both for a given function on the given interval. F of x is equal to 7x squared minus 14x plus 5. All right. First of all, we know that number 1 here, f is continuous function because it's a parabola. So in that given interval, it is continuous. Now let's find the critical value. So that means I take the first derivative and set it equal to 0. So critical value means f prime of x equal to 0, and we solve for x. So f prime of x, that's 14x minus 14. And I'm going to set that equal to 0 and solve for x. At 14x equal 14 divided by 14, x is equal to 1. Now, let's calculate the function value. So this is my critical value. Step 3 says evaluate f at an endpoint a, b, and the critical value found it in step 2. So we need to check the endpoints. So that means I need to, here's my endpoints of our interval. So I have 3 value for x to check. My critical value is one of them. So I need to consider f of 1. I also have to check my endpoint to see it is possible that these maximum minimum can occur at the endpoint. So 3 value to check. Critical value, which is x equal 1, and the ending point -2, and then -5. So let's plug it in. So f of 1, if I plug it into this, that's 7x squared minus 14x plus 5. So that is 7 minus 14 plus 5. I get -2. If I plug it in -2 into the original function, I get 7 times -2 squared minus 14 times -2 plus 5. So that is 28 plus 2 negative makes positive. 28 plus 5, I get 61. At 5, 7 times 5 squared minus 14 times 5 plus 5, I get 175 minus 70 plus 5, which is equal to 110. Now, let's take a look. Epsilon max and epsilon mean is the largest value from step 3 and then smallest value. So let's take a look at which one is the largest value. Largest value is this one right over here. 110 is the largest value. So that is our absolute maxima. And then what is the smallest value? Right over here. Absolute minima. Okay? So that's it. This one is neither. It's probably like one of the relative minimum or maximum. But we're looking for smallest or largest. Now, let's take a look at their value. So over here, f of 1 is where it occurs. So x value is 1. And then the associated y value is -2. So you can say 1, -2 is the absolute minimum point. And then 5, 110 is the highest value, which is absolute maxima point. Okay, so that's it. That's all there's to it for finding epsilon max or epsilon mean. Now this is our very first example, so I'm going to be using graphing calculator to check and see if these order pair really is the highest and smallest point of our function. So let's open up our calculator, and then I will erase it. 7x squared minus 14x plus 5. Our interval was a negative 2 to 5, so I'm going to change that, focusing on only our given interval. Let's graph it. And I'm going to I know that I should have like 110, so I'm going to, because that's what I found. So I'm just going to put 150, and then let's count it by 25. Graph it. So this is what we have. This is what we have right over here. So our smallest point, you can kind of eyeball it. It's somewhere right over here. That's like where our smallest point happens. And that kind of looks what we found. Positive 1 to negative 2. So that is indeed my epsilon minimum. And the highest point, you can see that it occurs at the end point at 5. So 5, 110. So it's a kind of approximated because I'm eyeballing it, but you can see that it's going to be 5, 110. So that's good. That's what we got. And then we confirm it with the graphing calculator. Okay. Let's do one more exercise. Okay, and this is the last example. This time they want you to find only the epsilon maximum value at a given function. So same thing, we are gonna do a whole thing together, and hopefully our critical value end up being the epsilon max. So same thing, let's begin, and this is our interval. So first we need to take the derivative to find the critical point. So derivative of this one is first one 6x, that's 6. Now second one, this is a product rule. Okay, so product rule. So 3x derivative of ln x is 1 over x, plus derivative of a first term is a 3, and then second one ln x. So let's keep going. Over here, you can see that the x cancels out. So you really have 6 distributing the negative minus 3 ln x. These two can be combined. So f prime of x is 3 minus 3 ln x. To find the critical value, we are going to set our derivative function equal to 0. So I have 3 minus 3 ln x equal to 0. So adding the 3 ln x to the both side, I have 3 is equal to 3 ln x. Let's keep going to solve for x. So I have 1 equal to ln x. Now ln is a function. So to get rid of ln function, one of the algebra trick is to apply e function. Apply e. Then I'm going to have e to the first power, raise it to ln, e raise it to the ln x. Then you know that these two cancel out, so I have e to the first power equal to x. Now e function is a irrational number, so I'm going to change to a decimal. E rounded to the 2 decimal place is 2.71 or 72, rounded to the 2 decimal place. So x is equal to 2.72. Okay, now let's plug it in. This is the only x value that we have. Okay, so let's take a look. This is one of the possibility, our critical value. And then another possibility that absolute maximum occur is the end point. But in here, look at this one here. It is open interval. It's not a closed interval. So we do not need to check our end point because 0 is not included. So end point, we only have to check when it's a closed interval. So that's it. So x, there's only one possibility. So that's it. That's our absolute max. So to find the absolute maximum value, we plug it in into the original equation, f of our x value 2.72. Let's plug it in into right over here. 6 times 2.72 minus 3 times 2.72, ln of 2.72. Put the whole thing into a calculator. I get rounded to the 2 decimal place, 8.15. So that's my y value. Here's my x. Here's your y value of our absolute maximum. So finally, let's write a sentence. 2.72, comma 8.15 is the absolute maximum point. And then you can also write the same result in a different sentence. You can say the absolute max is 8.15 at x equal, it occurs at x equal 2.72. Okay, either one is acceptable. All right, that's it. That's for section 4.5, and then next section we'll go over 4.6.